Hello everybody, very important lesson today, very common Regents question. I can model sequences using explicit and recursive formulas and using 1 plus or minus the rate to find R. Let's start with our formulas. Let's start with explicit. Explicit is on your reference sheet. They're given to you. You don't have to have them memorized. Arithmetic, geometric, an equals a1 plus n minus 1z. And geometric, an equals a1 r to the n minus 1. Recursive a1 equals an minus 1. And then you're telling me what you're doing to the previous term. If you're adding 5, you're going to write plus 5. If you're multiplying by 3, you're going to write multiplying by 3. So those are your formulas we dealt with in earlier lessons. Next, let's talk about using 1 plus or minus the rate to find R. If I want to find 20% of 50, this is going back to 7th grade, and it's something we've done earlier this year, then I'm going to make the percent into a decimal, which we've been doing all quarter, and we're going to multiply that by what I'm finding the percentage of. And 0.2 times 50 is going to give me 10. Now, if I want to increase 50 by 20%, and if I want to decrease 50 by 20%, whenever you are increasing or decreasing by a percent, you are adding or subtracting to 1. We've done this already earlier this year when we did exponential word problems. So if I'm increasing by 20%, I'm doing 1 plus 0.2, which is 1.2. I'm then taking that 1.2, I'm multiplying it by 50, just like I multiplied the 0.2 by 50 here, and that gives me 60. If I'm decreasing by 20%, then I'm doing 1 minus 0.2, which is 0.8, and I'm doing that 0.8 times 50, which is 40. So you might be saying, well, can't I just do 20%, which is 10, and then add it to 50 and subtract it to 50? Yes, but for the types of questions that we're going to be doing and you're going to be seeing, you need to understand that you're multiplying by 1.2, that you're multiplying by 0.8. It's not going to work doing it, finding the 20% and then adding it or subtracting it. So let's just practice this a little more. And again, we literally did this earlier this year. That's a little sloppy. Increasing by 15%, decreasing by 20%, increasing by 6%, decreasing by 5%. So I will just do the first one for you. If I'm increasing by 15%, I make that 15% into a decimal, and because I'm increasing, I add it to 1. Now we get 1.15. So I'm going to multiply whatever is increasing by 1.15. Why don't you try right now on your own, whether it's mentally or on paper, decreasing by 20%, increasing by 6%, decreasing by 5%. I'll give you about 30 seconds. Okay, decreasing by 20% is going to be 1 minus 0.2, which is 0.8. So if something's decreasing by 20%, I'm multiplying it by 0.8. If something's increasing by 6%, it's 1 plus 0.06, which is 1.06. If something's decreasing by 5%, it's 1 minus 0.05, which is 0.95. And for decreasing, why don't you try thinking of it this way? If you're losing 20%, you're keeping 80%. If you're losing 5%, you're keeping 95%. All right. Finally, if you're maintaining a certain percent, then it just stays. Like the original problem, if I'm finding 20% of 50, if I'm maintaining 20%, then I'm just multiplying by 0.2. But when you're increasing or decreasing by a percent, that's when you're adding or subtracting to 1. All right, so a lot of little things to talk about first. We talked about the formulas for explicit and recursive. We talked about increasing and decreasing by a percent. Now, let's talk about the difference between linear and exponential. These are literally Algebra 1 questions here. And we're going to use those to compare this to arithmetic and geometric, because linear is the same thing as arithmetic, and exponential is the same thing as geometric. So literally, linear functions are arithmetic, exponential functions are geometric, 100% of the time. So if something is linear or arithmetic, you are adding a common difference. You are adding a common amount. So the height of a ball that is thrown in the air, well, if a ball is thrown in the air, it goes up, then it comes back down. That is not linear. Linear will go in the same direction always. The price of a car that depreciates by 20% each year. No. Percents are exponential. And I'm going to kind of write that down. In fact, let's write that down here. Linear / arithmetic. You are adding or subtracting a constant amount. Not a percent, but a constant amount. Exponential / geometric. You are increasing, decreasing by a percent, or it's multiplication. If you see a percent or multiplication, that's exponential or geometric. If you don't see a percent or multiplication, if it's a constant amount that you're adding, then that makes it linear or arithmetic. So choice 2 is not arithmetic, it's not linear, because it's a percent. Percent has to be exponential. The amount of money Jonathan pays for a certain number of gallons of gas at $3.85 per gallon. Every gallon, he's paying $3.85. $3.85, $3.85, $3.85. That is linear. That would be arithmetic. A bacteria colony which doubles. Doubles is multiplication. Doubles means exponential. That's not linear. Choice 3 would be your answer. Which situation could be modeled with an exponential? For exponential, you are looking for a percent or for multiplication. The amount of money in a savings account where 150 is deducted every month, minus 150, minus 150, that is linear, that is arithmetic. The amount of money in Susie's piggy bank, which she adds $10 to each week, plus 10, plus 10, arithmetic, linear. The amount of money in a certificate of deposit that gets 4% interest, percent is exponential, is geometric. The amount of money in Jacqueline's wallet, which increases and decreases by a different amount each week, it's not increasing or decreasing by a constant amount, so that is neither linear nor exponential. Choice 3 would be exponential. So, linear is when you're adding or subtracting a constant amount. Exponential is where it's a percent or multiplication. So, we did a lot of talking. Now, let's see some very commonly asked reasons questions. The formula below can be used to model which scenario? So first off, this is recursive, because there's a1 equals, and then there's an equals an minus 1. So what am I doing to the previous term? I'm multiplying it by 0.8. So am I multiplying it by something that's more than 1 or less than 1? I'm multiplying it by something that's less than 1, which means it's decreasing. By what? What am I subtracting from 1 to get 0.8? If I'm keeping 80%, what am I decreasing by? I'm decreasing by 20%. So when I see a 0.8 that I'm multiplying by, since it's less than 1, it's decreasing. And what am I taking away from 1? 0.2. What am I taking away from 100% to get 80%? 20%. So whatever scenario where A1, the first thing is 3,000, and then it's decreasing by 20% is going to be your answer. So why don't you read through the choices and see which one you think it is. I'll give you about 20 seconds to do that. The answer is choice 4. I'm going to go through each choice and tell you what the proper equation would be to represent the situation. If each row has 80 more seats than the row in front of it, then it's going to be the previous row plus 80. 80 fewer seats, so it's going to be the previous row minus 80. A bank account starts with a deposit of 3,000, and each year it grows by 80%. If it grows by 80%, it's increasing by 80%. So it's 1 plus 0.8, which would be 1.8 an minus 1. 20% less is 1 minus 0.2, which is 0.8. That's your answer. The more practice you get with these, the more sense they're going to make. Now, I don't love this question. N plus, instead of n and n minus 1, it's n plus 1 and n. In either case, this is one more than this. So this means the same thing as n and n minus 1. I want you to try this one on your own. First of all, think about what that 0.75 means. Is it increasing or decreasing? And by what percent? Think about that. Take a look at the problem. I'll give you about 20 to 30 seconds, and then I'll go over it. Okay. Because I'm maintaining 75%, it's less than 1. This means that I am decreasing by 25%. That's what you need to know when you see something's being multiplied by 0.75, it's decreasing by 25%. Your answer is choice 4. For choice 1, it's increasing by 75 cents each week. That would be Rn minus 1 plus 0.75. Reduces by 25 cents. That would be Rn minus 1 minus 0.25. It's not reducing by 25%. It's reducing by 25 cents, a constant amount. A 15-gram sample decays at a rate of 75% per hour. So that's 1 minus 0.75, which would be 0.25 Rn minus 1. That's why choice 4 is your answer. I'm going to skip the one, let you do that on your own. The height of Jenny's sunflower when she planted it was 6 inches. The sunflower grows by 0.25 inches per day. Which formula can be used to determine the height in inches? As you can see, these are all recursive formulas. Now, when you're writing a recursive formula for a string of numbers, we always start with A1. In a real-life situation, you could have A0. If no time has passed and it represents time, then you can have H0. These are all H0 because when she was planted it, no time has passed. That's why it's H0. So it's growing by 0.25 inches per day. So all you have to do is tell me that the previous term is increasing by 0.25. Don't overcomplicate it. Don't combine explicit with recursive. Which one of these is telling me that the previous amount is increasing by 0.25? Choice 3. Choice 1, this is saying that it's decreasing by 75%. Since it's keeping 0.25, that means it's decreasing by 75%. This one is saying that it's multiplying by 6 and adding 0.25. Don't overthink this. Recursive, you're just taking the previous term and telling me what you're doing to it. You're not multiplying the previous day's height by 6 and then adding 0.25. That's what this is saying. This says, okay, well, the first day was 6. So now the second day, we're going to multiply that 6 by 6 and then add 0.25. And the next day, we're going to multiply that height by 6 and add 0.25. No, we're just taking the previous day's height and we're adding 0.25 to it. Choice 2 is saying that we're going to decrease it by 75%. And then for some strange reason, add 6 to it. If you understand recursive, choices 2 and 4 do not make sense, but a lot of students are going to put them because they're going to confuse them with the explicit. For recursive, just tell me what you're doing to the previous term. Your answer is choice 3. I want you to try... I'm just going to pause for 1 second. Okay, we're back. All right, so I want you to try... I want you to try numbers 5 and 6 on your own. So please pause, try number 5 and 6 on your own, and then unpause. Okay, now that you tried number 5 and 6 on your own, I'm going to go over them together with you. A lumber yard has 1,500 2x4 pieces of wood that need to be transported to a construction site. A truck can take 100 pieces of wood per trip. Which sequence can be used to determine the number of pieces of wood left at the lumber yard after n trips? Well, these are all recursive. We're starting after 0 time has passed. There's 1,500 of them. And each trip, the amount is decreasing by 100. So which of these is saying that each trip, the amount of wood is decreasing by 100 pieces? Choice 1 is saying that. I'm starting with 1,500, and then the next trip is going to be 1,500 minus 100, 1,400. Then it's going to be 1,400 minus 100, 1,300. Choices 3 and 4 make no sense. Choice 3 is saying I'm going to take the previous amount and I'm going to multiply it by 100. And choice 4 is saying I'm going to take the previous amount from the previous trip and multiply that by 1,500. That's a lot of wood. Those make no sense. Choice 1 is your answer. Number 6, the average depreciation rate of a new boat is approximately 8%. It's depreciating by 8%. So we are subtracting 0.08 from 1, Or think of it as if I am losing 8%, what am I keeping? I'm keeping 92% or 0.92. If a new boat is purchased at a price of $75,000, which model is a recursive formula representing the value? So first of all, choices 1 and 3 are not recursive. So, in fact, choice 2 is not recursive either, because a recursive has to have an an minus 1, and choice 4 does make sense. I am taking the previous amount and I am multiplying it by 0.92. All right, with that you can go back to later. This is, I guess we could take a look at this right now. This is pretty much like what we did in the last lesson. It's a word problem version of it, but it's really pretty much the same thing. The values below represent the cost of an ice cream sundae with 1 through 4 toppings. Write an explicit and recursive function that can be used to determine the cost of an ice cream cone. So, the first thing you have to determine is if it's arithmetic or geometric. To do that, subtract, 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 divide, divide, divide. Subtract them. Subtract 550 and 475, 625 and 550, 7 and 625. See if they subtract to the same amount. If so, it's arithmetic. Divide, divide, divide them. If they divide to the same amount, then it's geometric. So why don't you take about 30 seconds and determine if it's arithmetic or geometric. Okay, so if I go to my calculator, I'm going to subtract, subtract, subtract first. If this thing turns on. So 550 minus 475, 625 minus 550, 7 minus 625. They all subtract to the same amount. That means it's arithmetic, and D is 0.75. D is 0.75. A1 is 4.75, and we remember from the last lesson that in order to write the equation of a sequence, I need A1 and either D or R. So it wants both explicit and recursive. So explicit arithmetic is an equals a1 plus n minus 1z. An equals a1 plus n minus 1z. An equals 475 plus n minus 1.75. You don't need to put it to other form. You're good. Recursive. Recursive a1 equals an equals an minus 1. Recursive always starts like that. A1 is 475. What am I doing to the previous term? I'm adding 0.75. So again, this is a question that really could have been on the last sheet, but it's just a word problem version of it. So that's that. So you're going to see the same thing in the next few questions. So why don't you try number 9 and 10 on your own right now? So please pause, try number 9 and 10 on your own, and then unpause. Okay, now that you tried number 9 and 10 on your own. 9, a theater with 15 rows has 10 seats in the first row, 12 seats in the second row, 14 in the third row, and so on. So it's 10 in the first, then 12, then 14, etc. Write an explicit and recursive formula. Well, this one's pretty obvious. It's plus 2. So D is 2, A1 is 10. It's arithmetic, so it's an equals a1 plus n minus 1d. An equals 10 plus n minus 1 times 2. Recursive a1 equals an equals an minus 1. A1 is 10. The common difference is 2, so I'm adding 2 to the previous term. That's your answer. Number 10, Dana begins an exercise program. The following table shows her progress. So I don't know, looking at it, if it's arithmetic or geometric. So I'm going to subtract, 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 divide, divide, divide. 11.7 minus 9, 15.21 minus 11.7. Nope. 11.7 divided by 9. 15.21 divided by 11.7. There we go. The common ratio is 1.3, and it's geometric. So A1 is 9. The common ratio is 1.3. Now, some of the answers are recursive, and some of them are explicit. So what we're going to do is we're going to kind of do it both ways and then see which one's there. All right, so let's start with explicit because it is geometric. It's an equals a1 r to the n minus 1. A1 is 9, r is 1.3 to the n minus 1. I don't see that there. That just has an n, not an n minus 1. That's arithmetic, which is not the case. So now I look at recursive. My pattern is that I'm multiplying by 1.3. Choice 3 is your answer. 11 is the same type of thing, or is it? Yes. 12 is the same type of thing. 13, I think 13 was a little tricky, but I'm not going to go over that one now. That one is the same thing. All right, now number 15, we kind of open up something that gets a little more complicated. So let's look at our explicit formulas again. We have an equals a1 plus n minus 1z. And we have an equals a1 r to the n minus 1. Both of these formulas deal with a1. Now you might be thinking, like, Mr. Schlansky, this seems really familiar to the last unit where we had principal parentheses 1 plus or minus the rate to the power of time. And this seems very familiar to per x plus the one-time fee from Algebra 1. And they are essentially the same thing. The only difference in your principal parentheses formula, this was your principal or initial value, your value after no time has passed. So if instead of a1, you have a 0, your computer freezes, apparently. If you have a 0 instead of a 1, it becomes a 0 r, and if I go back to the previous term, then my n minus 1 becomes n. Similarly, if I do a 0, then again here, my n minus 1 becomes just n. And this is the exact same formula as this. R is what you're multiplying by. And here, so this is where it gets confusing. This R is the common ratio. It's what you're multiplying by. This R is the percent. So if I'm increasing by 20%, then this becomes 1 plus 0.2, which is exactly what this is. This is the same thing as y equals mx plus b, or if you had me in Algebra 1, which probably no one ever did because I don't teach Algebra 1 anymore, but I used to, per x plus the one-time phi. Whatever your per is goes in front of the variable, and your one-time or starting amount is being added to that. So, here's the deal. For your recursive formulas, they're not affected. For your explicit formulas, if they give you a0 instead of a1, n minus 1 becomes just n in both cases. These are not on the reference sheet. The top ones are. Those are on the reference sheet. If it's a string of numbers, this will not apply. But if it's a word problem, a real-life scenario, and they're giving you a 0, then n minus 1 becomes n in your explicit formulas. Recursives are not affected. So, I'm just going to copy this page because I want to keep those notes up there in case we need to refer back to it. Did that work? My computer is just done. It's like, Shlansky, I'm done with you. All right. So, that being said, a bouncy ball rebounds to 90% of its height, to the height of its previous bounce. Craig drops a bouncy ball from a height of 20 feet above the ground. Write an explicit and recursive formula for the rebound height of the bouncy ball. 20 feet. How many bounces has happened at 20 feet? Is it 1 bounce or is it 0 bounces? It's 0 bounces. So A0 or H0 is 20, not H1. It doesn't say after 1 bounce it's 20. The initial height after 0 bounces is 20. It rebounds to 90%. It doesn't say increases by 90%. It doesn't say decreases by 90%. So R is 0.9. So it wants an explicit and recursive. Let's start with recursive. Recursive. Instead of A1, I'm going to write H0 because that's what I have. Hn equals Hn minus 1. H0 is 20. I'm multiplying the previous amount by 0.9. There's my recursive formula. Now explicit. Because it's giving me H0, I'm using this formula. Hn equals H0 R to the n. Not n minus 1 because it's H0 instead of H1. So it's Hn equals 20.9 to the n. I don't know why I circled that whole thing. That's your answer. So, if you get H0 or A0 instead of A1, your explicit formulas change. The A1s become A0s, obviously, and the n minus 1s become just n's. Other than that, it's exactly the same, and the recursive formula is not affected at all. 16. A laboratory culture begins with 1,000 bacteria at the beginning of the experiment, which we denote by time 0 hours. So is 1,000 A1, or in this case P1, or is it P0? Time is 0 hours, it's P0. By time 2 hours, there are 2,890 bacteria. So P2 is 2890. Find the explicit formula for Pn of the sequence, write a recursive formula. So this one's got another little twist. We've got 0, 1, 2, 102890. I need to find R. So, and I know it's going to be R because bacteria, I mean, this I probably should have said in the problem, but bacteria grows at an exponential rate. It doesn't say in the problem, but it should. So I have to multiply, whenever I have a missing term, I'm going to multiply by those missing R's, so it's going to be 1000 R squared equals 2890. I solve, and we did this in the last lesson, the practice lesson. 2890 divided by 1000, 2890 divided by 1000, 2.89, square root, $1.7. So, explicit, because I have P0, the n minus 1 becomes n. So Pn equals P0, R to the n. Pn equals P0 is 1000. R is 1.7 to the power of n. That's your explicit. Recursive, I'm just going to erase to create some more space. Recursive A1 equals, in this case, P0 equals Pn equals Pn minus 1. P0 is 1000. I'm multiplying by 1.7. The whole n minus 1 becoming n thing does not apply to the recursive. It only applies to the explicit. Recursive is not affected by that. The only thing that is affected, of course, you're going to write P0 instead of P1. And that's it. I'm just going to do this one graph with you here. If you're looking at that in terms of a sequence, you're looking at the, that's a typo. You're looking at it in terms of the y values. So, first of all, I'm going 1, 1/2, 1/4, 1/8. If you can't tell what it is mentally, you can just, it's definitely not linear, it's exponential. You can do 1/2 divided by 1, 1/4 divided by 1/2. Your R is going to be 1/2. A1 is going to be 1. So it wants recursive and explicit. It wants the variable to be t. So, I don't know, I guess I write AT. So let's start with explicit. Do I have A1 or A0? Well, I have A1. So since I have A1, I'm going to be using these formulas. It is geometric, so it's going to be that one. So it's going to be an equals A1, R to the n minus 1. An equals 1, 1/2 to the n minus 1. But again, they want to t, so I'm just going to make it AT equals 1, 1/2 to the t minus 1. Because it literally said me it's 1. When x is 1, it's 1. That's why it's A1 and not A0. Usually it's A1 unless 0 time has passed, unless you specifically see a 0. Recursive A1 equals. So now we're going to do the recursive. An equals an minus 1. A1 is 1. I am multiplying the previous term by 1/2. There it is. Listen, there's a lot to this. It needs to be practiced. There's a lot of little components that come together, which is why we spent so much time before this. So let's kind of, again, sum up all the important stuff that you need to know. First off, you need to know your formulas. Explicit are given to you on the reference sheet. These are your explicit formulas, unless they give you a 0 instead. If they give you a 0 instead, then the n minus 1s become just n's, which is shown on this slide right here. Again, if a 0 is given, then the n minus 1s become just n's, and these become your basic, essentially the same as your basic exponential and linear functions they did back in Algebra 1. So that was the first thing we talked about. Second thing we talked about, increasing or decreasing by a percent. If you're increasing or decreasing by a percent, you're adding or subtracting that decimal to 1. We talked about the difference between linear and exponential, and linear is always arithmetic and geometric is always exponential. Linear or arithmetic, you're adding or subtracting by a constant amount, whereas exponential or geometric, you're increasing or decreasing by a percent, or it's multiplication. Doubling, tripling, a third would always be exponential or geometric. From there, we put it all together. If I see 0.8 in front of something, I know it's maintaining 80%, so it's decreasing by 20%. We set up a lot of those types of things here. Then we got into the whole A0 thing. If it's A0, again, the n minus 1 just becomes n. The recursive is not affected. And if it's a graph, you're basically just looking at the y values. Those are the terms of your sequence. This obviously needs to be practiced, practice, and I hope everyone has a great day.